Hi, this is Dennis and welcome to my third video on the United Manufacturing Hub. In this video, we will create a new process value topic that reads and parses data from one of the three provided sensors within the United Manufacturing Hub. We will continue from where we left off, meaning we have the deployment on Kubernetes running inside a Flatcar virtual machine. And this virtual machine has been configured with a static IP. If you want to know how we got to this point, you can rewatch my previous two videos. So I have the VM running here. We can see that the IP is 192.168.178.13. But for my convenience, I've mapped this IP address to an actual name in my hosts file, namely Flatcar. This is handy because I can just in the browser, instead of having to type all these numbers of the IP address, I can just type Flatcar, and on my local system it will be resolved to this correct IP address. So let us begin by opening the deployment on Kubernetes in OpenLens to view what kind of services we have running. All right, so I have the United Manufacturing Hub bookmarked here. We are now connecting to the cluster where we can see the various services on the network. In this video, we said that we want to parse data from the MQTT sensor. This means that we will use the technology called Node-RED, which is really a very handy graphical tool for connecting data sources and also do some processing. Let us take a look at Node-RED. It's one of the services which is provided with the United Manufacturing Hub. So let us see on which port number this runs so that I can connect to this service in my browser. One note, we could technically do port forwarding from inside the cluster to the local machine, but I find it more convenient to just browse the services directly on the IP address of the machine. So let's look at Node-RED. We see that Node-RED is deployed on port 1880 on the virtual machine. So if I now go to my Flatcar address, which will be resolved to the IP address of the virtual machine, I type in 1880, and for Node-RED we have to add the /Node-RED to go on the next page. Let us create a new flow. I have the old flow here. Let me delete it to start the exercise from new. So I'm going to delete this flow. Right. We want to create a new flow that processes data from the humidity sensor. For this, we can click on this menu here, go to the Flows tab and select Add. It's called by default Flow 1, so let's give it a more meaningful name by renaming Flow 1 to Humidity, right? Or to make it more telling, let's call this Humidity of furnace in Hamburg. Done. Good. So as we process data from an MQTT sensor, our source of the data will be this block here, MQTT in. But in order to see what kind of topics we have available, in other words, in which topic we can find this data on Red Panda or Kafka, in this video I will mostly mention it, call it Red Panda, but it's really interchangeable with Kafka. Now, to make it more visible what kind of topics we have, I like to look at the Red Panda console. If you look here, the console is deployed on port 8090. So if I open a new tab in my browser and I again navigate to the machine Flatcar and go to port 8090, I will see that I will land in the Red Panda console. And this really is a convenient overview of all the Kafka topics we have available at this moment in our deployment. You will see about 10. I have 14 topics because I've played around a bit and I have a bunch of topics which I have created. But the topic that we find is interesting for our use case is this one here. The IA raw development IoT sensors dot humidity. This is really the value that we will try to process with Node-RED. So let's go ahead and open this topic and copy the raw data, copy its name. We then return to Node-RED and we set the topic, the source topic for this node as this topic here. Now pay attention, we copied this from Red Panda and Kafka, which uses the syntax dot, right, between the various words. Well, in Node-RED, or actually in MQTT, you have to replace the dots with forward slashes. So it will be IA /raw /development and so on until we have humidity. Done. Now let's take a look at how this data is coming into Node-RED. For this we can use the debug block. Let's connect it. And now we basically have our first workflow. It won't do much. It will just read the data and display it in this debug node. So let's go ahead and deploy this now. And now if we go to the debug tab, we see that indeed every few seconds we become a value for the humidity. Now this value will by default be a JSON object. So there is still some processing to be done, because remember the end goal that we try to achieve here is to create a process value, which is part of the data model provided by the United Manufacturing Hub. And it has a very specific standard, which means that if we want to have this data for long-term storage later in timescale DB, right, it will have to adhere by a certain name to a certain name. That means that the topic itself must have process value in its name, but also the structure of the message which is sent back to Kafka must have a particular structure. And we can find the structure if we go here in the architecture and look at the data model. We want to create a process value. Let's see the data model for the messages. We see the various types of messages which are currently supported by Red Panda. And we are interested in the process value. So by opening the process value, again, we see that MQTT uses forward slashes. We see that basically the message has to consist of two keys. The first key will be timestamp underscore milliseconds, which is an integer. And the second key, its name we can choose ourselves. In this case, I think something like humidity probably makes sense. And its value can either be an integer or a float. And this is an example of how the message should look like in JSON after processing in Node-RED. So the name of the game is to really convert this JSON object we see here with class number to a message that looks like this, and then write it to a topic that ends with process value so that it will be automatically processed by our deployment. For this, there's two steps we need to do. Let's deconnect the debug node for now. And at first, we want to parse the JSON object into just a JSON string. And for this, we can use this convenient parser, JSON, which will basically, if you read the help tool, it will convert between a JSON string and its JavaScript object representation. So once we connect that, we can again take a look on how the data looks now. So let's go ahead and redeploy this. And now we see that indeed the value is no longer a JSON object. It's now a JSON string. We can see it with the quotes. Now we are not quite there yet because we now still need to have it in this format. So there's a couple more things we have to do, some logic we have to apply. And for that, for some custom logic, we can define a function in Node-RED, which is a function here. But let's connect it to our JSON string. And I would call this function create humidity process value, right? And the way it works is that it reads the payload, it reads a message and it returns a message. But we can modify the payload of this message basically with code. So a couple of things we need to do. We will say that from the message, this payload will be equal to, and then we open the brackets, because those brackets are in fact these brackets here. And we will define our keys. The first key that we will define will be a timestamp underscore milliseconds. And we will basically parse this timestamp from the date of the message. For this, we can use the function date now. And this will return a Unix timestamp in milliseconds. Now, the second key is a key that we can choose ourselves. And let's just name this key humidity, right? And the humidity we can obtain from our message payload. But don't forget that we can see our message is a string, right? And the model, the data model, expects this key, the second key of the process value, to be either an integer or a float 64, which means that we still have to convert the string to a float. And for this, there is a function available in Node-RED. I think it was called parse float. There we go. So we will parse float this message payload. Okay. And then we will return the message. So what happens is we read the payload from the message and we overwrite it by this structure that fits the data model as specified in the documentation. Okay, that's done. Let's again connect the debug node to see what it looks like and redeploy. And now we see that indeed we obtain a nice timestamp in milliseconds. It's an integer. And we see that the humidity is a float. This means that we now have the correct structure that we can use for our deployment. So again, the only thing that remains to do now is to write these messages to a topic in Kafka. And we will communicate these messages to Kafka using MQTT again. So let's deconnect the debug node here and add an MQTT out node. So this MQTT out node will basically serve as the sink of our for our messages. Now let's take a look again in the Red Panda console to see what kind of topics we have. Recall that we've used the raw humidity topic to read the data. And we can now basically create a new topic or use an existing topic to write the data. Now, I have played around and I created a raw topic earlier, but let's create a new topic altogether and call this topic process value for the location Hamburg. This way, this data will be or should be available in the timescale.db database. So the way the topic would look like is that, actually I have it here. So let's say this humidity comes from a melting furnace in Hamburg and it's a process value. We can add to the topic name the name of the actual property which is being tracked, in this case the humidity. So the topic we will use will be this topic here. It already exists, but to make it more realistic, I will delete it for now so that all the messages will be gone. There we go. When I refresh, this topic will be recreated because it's never truly, Kafka never truly deletes data for integrity. But nevertheless, if you look at the topic now, it has 0 messages, right? So it has no data. So hopefully, when we now recreate this sink in Node-RED and write data to this topic, we should see these messages appear here in Red Panda. So let's copy the name of this topic, go to Node-RED and enter this topic here. Again, remember, we are working with MQTT nodes, so we have to replace the dots with forward slashes. Melting furnace, process value, humidity. So the way to interpret the naming of this asset hierarchy is that we have a client factory inside. The client has a location in Hamburg. In this plant in Hamburg, there is a melting furnace. And for this melting furnace, we track process values. And one of these process values is the humidity, so to speak. Again, we can click on Done. Let's connect this node here to Node-RED. And when I redeploy this flow in Node-RED, I would expect the messages to be written to this topic, and they should be visible in Node-RED. In Red Panda, I mean. Okay, so now we are writing messages to this topic. I still have 0, but then if I refresh my topic, I now have 3 messages, I can see. Again, I can refresh, now I have 4. They're not very visible. Let's just see the newest 50. There we go. Now we can see the messages being created and being written to this topic in Red Panda. So to recap what the video, what have we done? We have taken our deployment of the United Manufacturing Hub in Flatcar. We have started it. We have looked at the Node-RED service, in which we have defined a flow that reads from one topic, processes the data a bit, and writes this topic to and writes these messages to a new topic. We managed to browse the various topics using the Red Panda console, which is very convenient for viewing all the topics currently available in your unified namespace. And we have paid attention to create a proper process value structure so that we adhere to the data model as described in the documentation. This will be very important because now these values are also automatically written to the timescale.db database, which we'll explore in a later video. Thanks for watching and see you in the next video.